Hey guys, this is Karan here. Now in this section we will be using the techniques we know from this. We know about the conic section up to this point, and here is how we analyze it. So you start off with an equation that looks like something like this. It says 7x squared minus 6 square root of 3xy plus 13y squared minus 16 is all equal to 0. Okay, so you need to rewrite this into 13y squared minus 6 radical 3xy plus 7x squared minus 16 is equal to 0. Okay, so you need to use a quadratic equation. If you don't know, it's minus b plus or minus square root of b squared minus 4ac over 2a. Okay, so this is the equation that we use. So let's go ahead and plug these values in. Y is equal to negative minus 6 radical 3. Now it's just going to be a lengthy form, so I'm just going to erase this and try to write it as small as I can. Okay, plus square root of minus 6 radical 3 x squared, okay, minus 4a, which is 13, c, which is 7x squared minus 16, all divided by 2 times a is 13. Okay, so if you do that and keep solving it, okay, since I'm running out of space, so I would just, at the end of the day, I would just give you a simplest answer that would basically look like this. You just go ahead and erase this up. Simplest answer, if you solve that one correctly, Vy is equal to 3 radical 3 x plus or minus 4 radical negative 4x squared plus 13 all over 13. Okay, this is the simplest form. Now when we talk about this type of forms, it's usually hard to understand the difference between a standard form and general form, right? So let's go ahead and talk about the general form. How does the general form actually look, and what's the extended general form that we can end up with? Okay, so let's go ahead and take a look at that one over here. So the general form for the extended would be some value of a x squared plus bxy, and then you have cy squared, and then you have dx plus ey, then some constant which is f, and is all equal to 0. This over here, what I just wrote is an extended form of some conic situation, some conic equation. Okay, now it turns out that we can use trigonometry in this over here as well. So we can use cotangent, which is written as cot of 2t, 2 theta would be equal to a minus c over here, a minus c, all divided by b. So if you do that, it would basically equal out as x is equal to x prime cosine of theta minus y prime sine of theta. You know how sine and cosine are related to each other, since we know a lot about them. To find out y, it would be y prime sine of theta plus y prime cosine of theta. So these are some just quick tips on quick tips on improving your skills at solving the demystifying the general form and finding the answer as quickly as possible. Okay, so let's actually use them into the previous example, and let's go ahead and keep solving them. And when it's an example, this over here, we are trying to find the theta, the angle between them. Let's go ahead and do that right now. So we said this was the extended form and this was the formula, right? So let's go ahead and plug in the formula for the equation we had. So it would be cotangent of 2 theta is equal to 7 minus 13, because 7 was the a value and 13 was the c value, over negative 6 radical 3. That would equal out as negative 6, negative 6, and here you have negative 6 radical 3. It would basically be 1 over radical 3. Since negative negative cancels out, cancel each other out. Okay, so now we have cotangent of 2 theta would be equal to 1 over radical 3, which we know comes out to be what? Well, it comes out to be 2 theta, which is equal to 60 degrees, right? Congruent of this would be 60. Now we have two thetas, would be divided on each side by 2, giving you 30 degrees for theta. Okay, so we can use the x prime and so on as well. That is, we can use something that looks like this over here. Whoops, let me go ahead and erase this right here and use, let's say we have x is equal to x prime cosine of theta minus y prime sine of theta. We said we can use this one, right? So let's go ahead and use that one for right now. For the previous example, that would be x prime cosine of theta, which we just found out would be 30, y prime of sine theta, which would be 30 over here, okay? And this over here, what we did was a demonstration as 2. So if we solve, go ahead and solve for this, we would get x is equal to radical 3 x prime minus y prime over 2. You put denominator as 2. Okay, so if you wanted to go for solve for y, you would go like this. The formula for y is equal to y is equal to y prime sine of theta plus y prime cosine of theta, right? We plug in the y is equal to we can x, so we can put x prime sine of 30 degrees plus y prime cosine of 30 degrees. Y, what we get would be x prime plus radical 3y over all over 2. Okay, now that was the equation that we started off with. Now let's move on to our next equation. And you can always rewind the video if you want to. Okay, so the next example, the general formula would be 7x squared minus 6 radical 3 x and y, both in bracket, plus 13y squared minus 16 is equal to 0. Okay, then we would say this radical 3x prime minus y prime all over 2 right here, because we have squared over here, minus 6 radical 3 from here. We have for the x and y, we got square root of 3x prime minus y prime from the previous one, if you remembered, all over 2. Okay, now you multiply that with the y one, okay, as well. So the y for y, we got x prime plus radical 3y prime all over 2 plus 13 y squared, which is x prime plus radical 3y prime, over 2. That would be squared over here. Then you subtract 16 would be equal to 0. Okay, and then you demystify this or solve this again, and it would take a time. But if you solve it correctly, what you end up is with an answer that looks like this. that would be 4x squared, x prime squared plus 16 y prime squared minus 16 would be equal to 0. Okay, then we can what we can do is plug this 16 over here. That would basically be 4x squared plus 16y prime squared is equal to 16. Now we don't want 16 on this side because we are dealing with the conic section, and we said that nothing should be coming over here. So if you divide this by 16, that would just leave 1. So the whole equation, if we rewrite it, cancelling it, it would be x squared over 4 plus y squared over 1 is equal to just 1 over here. And we found out the value of a. This is hyperbola, and the value of a would be 2, value of b would be 1, and if you find out the c value, which is c squared equals a squared plus b squared, would be c squared is equal to a 4 plus 1 would be 5, c is equal to square root of 5. Okay, so whoops, it would be a squared minus b squared because it's hyperbola, sorry, it would be square root of 3 right here. Now when we first started the discussion, we looked at x and y term and we began evaluating the equation using the information from the previous section. The rotation invariance basically is like this. The first would be, the rotation would be for f prime would be equal to f. The second one would be a prime plus c prime would be equal to a plus c. Third one would be b prime, which is being squared, is minus 4a bracket. C prime would be as equal as b squared minus 4ac. Okay, so these are rotational. Now they're equivalent, but they're being rotated, yet they're equivalent, is what I'm trying to tell you guys. Now, how to find out, what's the quickest way we can find out if the whole general form is thrown at us, and how do we actually find out if it's a parabola, ellipse, or circle, or hyperbola? Well, a thing called discriminant, which basically is b squared equals b squared minus 4ac. You use that for the discriminant. Okay, that's basically what you call that, is discriminant. Discriminant. Okay, you use this in your general formula, so you can find out whether it's a parabola, circle, or ellipse, or hyperbola. Now, how do we find that out by? Well, if it's a parabola, the first one, it would be basically b squared minus 4ac. Whatever you get would be equal to 0. Okay, second would be circle or ellipse, which is b squared minus 4ac, which basically is less than 0. Okay, third one would be hyperbola. For this one, it would be b squared minus 4ac would be greater than 0. Now let's see if I can switch the markers because it's getting light over here. Okay, so I hope this marker doesn't run out as well. So let's go ahead and use this into our real equations. Okay, so what if an equation is thrown at you, such as, and this is something that you should remember. Just remember discriminant It's always something. Now the best thing to remember this would be the quadratic formula. Is that if you remember the quadratic formula, which is this one, the discriminant would be something which is under the square root. Okay, and this is just a tip, so you don't feel like you have to memorize a lot of things. Okay, so let's go ahead and use the real equation. So this one would be 4xy minus 9 is equal to 0. Okay, and the first thing you would do is basically second square minus 6xy plus 9y squared minus 2y plus 1 would be 0. Okay, now we would use, let's go ahead and erase this one over here. Let's use the biggest one over here first. So we would use the discriminant, which is b squared, remember this, minus 4ac. B squared, we would rearrange this formula and you will find that the b squared would be 4 squared minus 4a, which is 0. C would be 0 as well. So 4 squared minus 0 would be 16 minus 0, which is equal to 16. Now 16, we said if something b squared minus 4ac is greater than 0, it would be hyperbola. And since b squared is equal to 16, since this is greater than 0, this situation over here, this graph, this function is of hyperbola. Okay, let's go ahead and solve one more equation on this for this first one. For this one, I'm confusing a lot of things here. That what I just did was the equation of first one, but by mistake I just erased it. Now for the second one would be b squared minus 4ac. Okay, and b squared would be minus 6. You square that, 4a would be 1, 9 would, c would be 9, is equal to 36 minus 36, and it would equal out to 0. And we said that b squared is minus 4ac, when it's equal to 0, it's a circle. It's a parabola. Now since this is the case, when this is equal to 0, it's a parabola. Okay, so again, sorry for the confusion over here, but if you enjoyed this video, give it a like, comment and subscribe. I really apologize for this mistake. Is that I erased the formula over here before starting the question. So, but whatever it is, what I want you guys to do is do me a great favor. Is that there is a Facebook URL for a Facebook page down below in the description area. Go ahead and click like on that page. It's my page, and it really helps me a lot. Thank you for watching. Make your friends like it. Make your friends and family like it. Thank you for watching. Peace out as always.